Welcome to the DIY Honda Garage channel. The Honda CRV model from 2011 to 2016 may encounter a diagnostic trouble code known as P1458. This error indicates a problem with the fuel tank pressure, FTP, sensor circuit performance or range. Specifically, it indicates that the readings from the FTP sensor are outside the acceptable range, either due to electrical issues or sensor malfunction. The FTP sensor plays a crucial role in monitoring the fuel tank's pressure to prevent fuel evaporation and maintain emissions control. This sensor is typically found in the fuel tank area, attached to the tank itself. When diagnosing this issue, it's essential to have the right tools, such as a vacuum pump and gauge, to accurately measure the pressure and identify the root cause of the problem. The DTC P1458 refers to an issue with the FTP sensor circuit, specifically indicating a range or performance problem. The FTP sensor is integral to the emissions control system, as it detects fuel tank pressure to manage fuel vapors. This sensor informs the engine control module, ECM, of the current pressure status, which assists in activating the evaporative emission control system to prevent gas vapors from escaping into the atmosphere. Located directly in the fuel tank, the FTP sensor's functionality is pivotal for the Honda CR-V's compliance with emission regulations. A malfunctioning FTP sensor could lead to increased emissions and potentially impact fuel economy due to improper fuel system pressure readings. There are several possible causes for the DTC P1458 to be triggered. One major cause is the malfunctioning or damage of the FTP sensor itself. This can include internal faults that affect its readings. Additionally, poor electrical connections, such as frayed wires or loose terminals, can disrupt the sensor's ability to relay accurate data to the engine control module, ECM. Another likely culprit could be blockage in the vent hoses or lines that connect to the FTP sensor, preventing it from measuring pressure correctly. Lastly, issues with related components like the evap canister vent shut valve can also influence the performance of the FTP sensor, necessitating thorough diagnostics. Symptoms of the DTC P1458 can manifest in various ways, primarily through triggering the check engine light on the dashboard. This illuminates as a warning that something is amiss in the vehicle's emission control system. Additionally, drivers may notice a drop in fuel efficiency. This occurs because the engine could be receiving inaccurate fuel mixture data, leading to power loss and increased fuel consumption. In some cases, an unusual fuel smell may arise from improper fuel vapor management, indicating that issues within the fuel tank or evap system could be present. Overall, recognizing these symptoms quickly can help prevent further complications and encourage timely repairs. The first step in troubleshooting DTC P1458 is to turn the ignition switch to the on sealing position without starting the engine. This allows access to the vehicle's diagnostic system. After this, you must record the parameters related to the FTP sensor using the HDS, which is the Honda Diagnostic System. Make sure to note the maximum and minimum values of the FTP sensor, and also check the fuel level parameter. It's critical to compare these readings against the recorded onboard snapshot. If the fuel level is higher than the snapshot readings, you'll need to drain some fuel until it is below the observed levels before proceeding to the next troubleshooting step. In this second step, you'll again utilize the HDS. Without starting the engine, take a snapshot for 3 minutes. This will provide you with updated readings of the FTP sensor. Check the maximum and minimum values from this snapshot to ascertain the performance of the FTP sensor. If the difference between the maximum and minimum values is approximately 0.67 kilopascals, 0.2 inch magnitude, or 5 millimeters inch magnitude or less, you can proceed to step 3 for further diagnostics. If the values lie outside this range, further investigation is warranted, which entails checking possible failure areas beyond just the FTP sensor. Step 3 focuses on evaluating the performance of the FTP sensor. Using your HDS toolkit, observe the FTP sensor's fine readings from the snapshot taken earlier. You need to see if the readouts vary by 0.067 kilopascal, 0.2 inches, or 5 millimeters of mercury, or more over a duration of 3 seconds. If they do show a significant variation, you'll continue on to the 4th step. However, if there's no reasonable fluctuation, it suggests that the sensor could be experiencing intermittent failure. In this case, checking for loose connections at the FTP sensor, the evap canister vent shut valve, and the powertrain control module, PCM, should be your immediate action. In the 4th troubleshooting step, turn the ignition switch to the lock 0 position and carefully remove the FTP sensor to expose its connections. Reconnect the FTP sensor's 3P connector, then turn the ignition switch back to the on 2 position. Again, use the HDS to monitor the FTP sensor's fine readings. You'll need to check if the sensor can still yield a variation of 0.067 kilopascal, 0.2 inches, 5 millimeters inches or more over 3 seconds. If this variation holds true, it is advisable to replace the FTP sensor due to its suspected failure. Conversely, if the readings are steady and show no change, you should further examine and ensure there are no poor connections before wrapping up this diagnostic cycle. The 5th step requires you to remove the fuel fill cap to alleviate any pressure that could affect sensor readings. With the cap removed, utilize the HDS to verify the current conditions of the FTP sensor. You'll compare the parameters against a threshold where the fine readings should indicate above 0.67 kPa and below negative 0.67 kPa. If the readings align with these conditions, reinstall the fuel fill cap, and you can then move on to step 8 for further diagnostics. If they do not match the desired thresholds, you should investigate other possible failure areas beyond the FTP sensor itself, including assessing the vent line system. For this 6th step, once again, turn the ignition switch to the lock 0 position and reconnect the FTP sensor that you removed earlier. This time, you will check for any issues that may exist within the FTP sensor vent hose. Similar to previous steps, turn the ignition switch to on 2 and take a closer look using the HDS, specifically to identify any discrepancies around the threshold values for the FTP sensor fine measurements. If the sensor indicates above 0.67 kilopascal or less than negative 0.67 kilopascal, you will need to remove any blockages in the vent hose connecting to the FTP sensor. If the hose appears damaged, consider replacing it as well to ensure proper function. In the 7th troubleshooting step, you should turn the ignition switch to the lock 0 position and disconnect the FTP sensor's 3P connector. This allows for a more thorough inspection of the FTP sensor ports, focusing on both the evap canister side and the vent side. Look for any visible blockages or physical damage that could affect the sensor's functionality. If you identify any obstruction, it's crucial to remove it immediately. If the sensor ports are undamaged yet still malfunctioning, consider replacing the FTP sensor entirely, ensuring proper verification of the repair by checking the sensor's outputs once it's been replaced. The final step involves checking the evap canister vent shut valve for proper functionality. Start by turning the ignition switch to the lock 0 position before disconnecting the fresh air hose from the evap canister. Next, connect a vacuum pump or gauge to the shut valve. Then, while turning the ignition switch back to on, 2, attempt to apply a specified amount of vacuum to the valve, ensuring you do not exceed the 5.3 kilopascals, 1.6 inches, 40 millimeters inches limit. Limit to avoid damaging the FTP sensor. Observe the FTP sensor's fine readings simultaneously. If the valve fails to retain more than 1.3 kilopascals, 0.4 inches, 10 millimeters inches of vacuum, this points to the need to replace the evap canister vent shut valve, as it's not holding pressure effectively. Should the valve prove functional, ensure to check for any blockages in the fresh air hose as the next logical step. After completing the necessary repairs, it's crucial to verify that everything is functioning as intended. Start by turning the ignition switch to lock 0 to reconnect all previously disconnected connectors and hoses, specifically the fresh air hose. Once everything is securely attached, turn the ignition switch to on 2 and utilize the HDS to reset the powertrain control module, PCM. This process involves not only resetting the systems, but also completing the idle learn procedure, which allows the PCM to relearn the optimal fuel mixture and idle settings post-repair. Finally, take a snapshot using the HDS for approximately 3 minutes without starting the engine, and check the recorded parameters. If the difference between the maximum and minimum values of the FTP sensor remains within approximately 0.67 kilopascal, 0.2 inches, 5 millimeters inches, you will have successfully completed the troubleshooting process. To prevent future occurrences of DTC P1458, implementing preventive maintenance is essential. Regular inspections of the Evaporative Emissions Control (EVAP) system can catch potential issues before they escalate, including visual checks for wear and tear or blockages in hoses. Periodically checking the sensor connections to ensure they are secure can help minimize electrical faults leading to inaccurate readings. If you notice any symptoms indicating potential failure, such as warning lights or fuel smells, address them immediately. Replacing faulty components at the first sign of trouble can save time and repair costs in the long run, ensuring your Honda CRV continues to operate efficiently and remain compliant with emissions regulations. In conclusion, DTC P1458 indicates potential issues within the FTP sensor circuit that can impact the vehicle's emissions control system. It's crucial to follow the outlined troubleshooting steps carefully to diagnose and rectify the problem accurately. The technical process requires specialized tools and a systematic approach to identify whether the fault lies with the sensor, wiring, or related components. Regular maintenance and prompt replacement of faulty parts are key to preventing future issues, ensuring that the Honda CRV operates efficiently within emission standards. By being vigilant and proactive in vehicle care, drivers can maintain peak performance and reliability while driving their Honda CRV. Please like and subscribe to the channel. See you next time.